where is it discontinuous? Is this piecewise graph discontinuous? And if it is discontinuous, is it removable or not? So what you have to realize, this is a piecewise, so you have two different graphs. Now, so you look at each graph individually and see, first, is each of these continuous? This is a line, this is a parabola. They're both continuous. So we're not going to worry about discontinuities on each one individually. So these are both continuous. This is a line, this is a parabola. They are both continuous. Okay? So all we care about is making sure they meet at 1. So basically all we do, find f of 1 for negative 2x plus 3, and f of 1 for x squared. When you plug in 1, you get 1. Plug in 1, you get 1. So the output's the same? Yeah. If the output's the same, doesn't that mean the two graphs meet? Thus, this is continuous. There aren't any discontinuities, or no discontinuities. Now, if this was a 1 and this was, say, a 3, it would be discontinuous at 1. And that discontinuity would be non-removable, because you cannot, it's a separated graph. But in this situation, it is continuous. It's nice. It has a jagged edge to it, but it is continuous. 62. Discuss the continuity of f of g of x. So f of g of x would be an equation of f, and instead of x, you're going to plug in x minus 1. And where would this graph be discontinuous? Where? It would be when the bottom is equal to 0 or negative, correct? So the bottom cannot equal 0 or be negative. So aren't those values, where is it discontinuous, would be values less than 0, correct? So where would they be continuous? Values greater than 0? Is that okay? These are going to be continuous. Are all values where this is greater than 0, would those be continuous? Yeah. Anything less than or equal to 0 would be discontinuous. Solve this. Okay, those are where it's continuous. Any values where x is greater than 1 will give you outputs. You have a continuous graph everywhere. Anywhere that it's less than or equal to 1, you will have nothing in the situation, which means it's not continuous because there's nothing there. You have to pick up your pen because your pen's not on the paper. So those would be where it's continuous. It's a different kind of continuous because there's nothing there in comparison to holes or asymptotes.